We need to get started. Sure. Cool. So welcome back, guys. Thanks so much for coming back for the fourth day. I know it's a lot of commitment to even get here in person for all the 4 days. So kudos to all of you who have been coming back. A lot of you have requested that today you would want to kind of view the session online. So a lot of people are watching the session online, and they're also going to be watching the recording. So today, we're going to be completing the journey we started 3 days ago. Now, we started out by kind of understanding what data science is about, and we've gone through this journey the last 3 days. And today, we're going to talk about how do we deploy and how do we productionize these applications in the enterprise, right? Most of you are quants, and most of you are data scientists. So what that means is you are coming with these interesting ideas. You are coming with these models. Now, the question is, how do we scale these models? How do we productionize these models and make it available so that the end users can actually use it? So there is going to be a little bit of technology involved in today's discussion. And to keep it simple, I'm just going to do a little bit of hand waving at times, because this is a crash course, and I won't be able to kind of cover all the technologies and the specifics on how do we go about implementing these solutions. But this is just to get you an idea on what does it mean and what does it take to get an application into production. Okay. So again, as always, the slides and the videos will be available on the Research Hub. And we have gone through the first 3 parts till now. So in the first class, we got an orientation on data science. We understood what it means to bring data sets into Python. We understood what it means to kind of explore the data, understand it through graphical and other summary measures, the nature of the distribution of the data sets we're going to be working with. And then in class 2, we kind of dive deep, and we started looking at some of the machine learning models which are out there. I know it's not going to be easy to just grasp everything. I've been reviewing some of the feedback you guys have been giving. But again, this is a crash course, so I just wanted to give you the basics of what is necessary for us to build out these algorithms. And I've given you some links so that you can go and dig deep into these topics. Now, the first couple of models you've been building, we kind of initialized these with the data sets we had in the workspace for the labs. And yesterday, we spent quite a bit of time on fine-tuning these models, kind of understanding the various levers we're going to be working with whenever we build out machine learning models. So today, we're going to kind of move further. So once you have brought in data, you have built out a bunch of models, you have tested it, and now you are ready to move this into production. So what does production in the context of the use case we've been working with mean? We have been primarily looking at the lending club data, which has parameters for various people on how their spending habits are, their earning capabilities, the various attributes associated with their data profiles. And we also know what interest rates they have been given when they actually solicited a loan, right? So the question is, can we build out an application which will give out interest rates based on all these criteria? So if we can input these parameters, can we get an interest rate? And that's what we did in 3 machine learning models. Now, obviously, if you are an end user, or you want to put this app in the hands of an end user, you want to kind of provide an interface through which they will be able to input these parameters, and you should be able to get out these outputs. So that's kind of the context today on how do we actually deploy and make predictions. Just to give you a context, we have kind of gone through these first 3 steps of the pipeline, and we are talking about deploying a model into production. Now, before we actually get into the specifics, I want to give you a little bit of perspective on what does it mean to bring these models into production. Because many a times there is this understanding that, well, it works on my laptop, works on my desktop, it should work in production, right? It's not that easy. And many times we even think that, well, in case I put this into production, we don't have to worry about tuning it further, and it's just going to keep on running. So I have put together a couple of slides just to kind of give you a perspective. And whenever you talk about machine learning models, you need to take a little bit of, you have to do your due diligence, because it's not a generic solution for all problems, right? So you can't just basically say, well, I have technology, I have the algorithms, I have the data. Let me just put all of them together and then deploy a machine learning application. Okay. So the question is, what kinds of applications are typically suited for machine learning? You have to have a lot of data, especially if you're trying to do prediction. You need to have a lot of labeled data sets. And then you need to also figure out whether your problem is a balanced data set or an imbalanced data set, and what kind of algorithms you can potentially use for the data sets you're going to be having. Then the second thing you want to understand is a prototype model is not a production model, right? Because you have worked on a small piece of the data set and you have a model which works for the data set you have been testing with, doesn't mean that you can basically take that and productionize it, right? So you have to do, you have to understand, well, how much data should we be using? What kind of bias aspects are going to be there in the data sets? How do you prevent overfitting? We did a lot of discussion about that yesterday. And then also, just because it worked in the past, and we have to repeat it again and again as financial professionals, right? Doesn't mean it's going to work in the future too, right? So you have to understand those aspects when you're building out a model in production. And there's been a lot of talk, and we have kind of presented some of these slides in our meetups. There's been a lot of talk in the industry, and a couple of statements from a few of them who've been trying and applying machine learning into production. So there's someone from HSBC who basically said, well, it works perfectly when you're looking at sample data and POCs, but when you kind of move into production, typically it doesn't work. Or even things like RPA, or robotic process automation. It works, beautifully when we do our POCs, but when we try to do things in production, it's not always the case. So there has been a lot of question about how do we move these interesting data science and machine learning models into production, and that's where there's a lot of education and also due diligence required before you can put these models into production. Okay, so the other thing you also need to know is, we talked about interpretability yesterday. We talked about when would you choose a parametric model versus a non-parametric model yesterday and the day before. You have to kind of understand the nature of the work you're doing and how much interpretability is required, how much transparency is required, how much auditability is required. And you have to weave those aspects into your development and production process. Otherwise, your model is going to be running, and typically when good things are happening, people don't question it. But when bad things happen, people will have to go back and figure out, like, well, we thought everything was working fine. What's happening in here? Then you have to start, going through a fishing expedition. So you have to build in those aspects in the process of building out these models. The fourth one is, we talked a lot about metrics. Typically, it's not just during the training and the testing process where you evaluate these metrics. When your model is deployed in production, you need to have the mechanism so that you're monitoring these metrics on an ongoing basis. You need to figure out, like, well, if these models have been deployed, does it retain the the loss metrics or the error metrics you had observed in the when you deployed this model, and how do you make sure that the model is healthy enough and you kind of are using it in the production setting, right? And then lastly, we're just kind of scratching the surface at this point, right? There's a lot of talk about, well, traders are going to be replaced by AI and machine learning. You don't have to do the work. The algorithms are going to take over. We're not there yet. There's a lot of work still needs to be done, especially in the context of what we're doing. We're mostly automating many of these aspects. We are kind of building out pipelines so that we can get the efficiency leveraging the technology. But we are not there yet when we talk about true AI. The decision making is not 100% there yet. There's a lot of augmented AI which is being positioned as true AI, but that's something you need to kind of take into perspective. Okay, so with that said, let's just kind of get a quick, check on where we are. So we went through the data cleansing process. We didn't do a lot of it in the context of the crash course, but the Kaggle link I had in the original data set, that has like, I think, 240 megabytes worth of data. So if you get the real data set or the large data set, you'll have an opportunity to clean up the data and leverage a lot more features than what we have been discussing in class. Okay? And then we briefly talked about feature engineering yesterday. You will have an opportunity to generate more features or try out more features with the amount of data you have. That's something you need to think about. And then also the training and testing. We kind of talked about the 80-20, and we talked about potentially using cross-validation and a bunch of other techniques. That's something you could experiment with too. And I talked about 3 models in the last 2 days, but that doesn't prevent you from stopping at those 3 models. You can explore more models and figure out whether you can come up with better results. Now, Kaggle also has some of these kernels which people have put together, so you can review other people's code and figure out like whether those kernels make sense and you can leverage additional models. And then yesterday we spent a lot of time on model selection, but then you can also think about, well, what is your decision criteria going to be? Is it going to be based on accuracy? Is it going to be based on kind of getting to a model which can actually be used, number of features, et cetera, et cetera. And then we'll talk a little bit about deployment in today's session. Okay, so I like this picture because typically when I was in my past role at MathWorks, most of the times I would be brought in because the quants have already done their job. The IT team needs to deploy these models, and they're not able to talk to each other. How many of you have had this problem before? At least a couple of you. So many a times what happens is, the quants think the models are ready for production. IT thinks, no, not yet, because we need to go through these various steps. And first of all, we don't understand what you're doing. It's not ready for what our frameworks are. We need to bridge the gap quite a bit, right? So that's where you will have to face additional challenges, especially if you're working with open source products, and you have to work with an internal IT team, especially in a regulated environment, if you want to make sure that you're building in the right processes before you can deploy these models into production. Okay, so what does it actually take? So that's where we are building out this framework called as Sandbox, which you've been using the last 3 days for most of the labs. So I want to kind of give a little bit of perspective on where this platform came about and show you a little more about what it means to kind of deploy these models into production from where you guys are. You're primarily doing the prototyping piece. You're kind of building out on a daily basis incremental enhancements to the model. Now, where do you go from here? Now you have a working model. You have tested out a bunch of different things. How do you kind of go into production, right? So let me kind of talk about something which is becoming a major challenge in the industry, and that's basically what's called as the replicability crisis or the reproducibility crisis. And what that means is typically when you're building out these applications, especially data science applications, it's not just a one-time solution, right? You need to be able to build a solution which is replicable, not just on your machine, but also your colleagues should be able to replicate the same results, and you should also be able to deploy these models into production, right? And that's where when you start taking your model which is ready for production and start deploying into production, you have to start figuring out, well, do I have the same environment? Do you have the same code base? Do you have the same kind of data sets? And you have to start kind of matching all the parameters which the quant or the data scientist initially used before you can replicate the results as is, and you can then kind of deploy these models to production. So typically, yes, Hugh.
How often do they get rewritten in, let's say, C or Python?
Well, the question was for the people online, how often do these models get rewritten into Python or from Python to C or right? Yeah, so C++ or other languages. So that's an excellent question. It depends on what the end goal is, especially if you're trying to build a trading algorithm, wherein Python may not be fast enough. And at that point, sometimes the models are completely rewritten in a language which could be compiled and could be much, much faster than a traditional just-in-time compiler, which Python uses for compiling and execution. The gap is kind of shrinking with faster hardware, but there's still that notion that especially if the performance is taking more prominence, then you'll actually prototype it in with Python or MATLAB or any of the languages, and then you're going to take that code and then rewrite it into a different language. Yeah. So when people talk about reproducibility, you have to figure out all these aspects. It's not just you writing the code and saying, here's the code, I want to deploy this into production, right? So you have to think about, well, what's the code base? What packages or the environment is my code using? So when you looked at the documentation for various labs, you're kind of specified, well, these are the packages we're going to be using, right? Python has more than 10,000 packages. R has more than 10,000 packages. So you can just download and start using it. It's not easy to just basically keep track of what all is happening. But when you're moving it into production, you need to make sure that the same environment you have tested and you have validated should be used when you're productionizing these applications. And then the question is data. What data did you use to build out these models? And what data are you going to be using in the future? Do we have the same or the similar kinds of data sets? And then finally, what processes have you followed? So yesterday, when I was talking about the various steps in the Jupyter notebook on here are the various levers, I'm using this particular parameter in here, I'm using this learning rate, I'm using this particular algorithm, all those are process parameters. I'm kind of saying that, well, based on all the things I've tested, these are the optimal set of parameters we're going to be using when we are building out these models into production, right? So those are all the key things you need to think about when you're building out these models. And what we have done is, in the context of the Q sandbox, we're basically taking all these things into consideration. When you ran these experiments, what you were doing is you had the code base, which our data scientists have written, and it's available on GitHub. We have Dockerized containers so that the environment is all captured. So that's why you didn't have to do any Python installation or any package installation. So everything was already packaged. So we were applying these code onto the environment. We had a static data set, so we didn't have to do anything with the data. And then we had process documentation written in Research Hub, which basically walked you through the entire process of replication, right? So everybody, 160 of you who have registered for this course, were basically running the same experiment with the click of a button, and you did not have to go through that whole process of replicating and creating the same environment. Just imagine what nightmare would it have been if we had just created a crash course and 160 of you should have been ready with a running application in the last 4 days, right? So the same problem is there in the enterprise too. When you start building out an application, you have a very interesting idea. You tried it out. Typically, you go into a conference room, you present your results, and someone says, well, how about we tweak these results? Then you have to go back to your desk, tweak it, and then you have to share it back. The outcomes are typically shared, right? So you'll have to think about creating a framework within the enterprise so that you are able to share and replicate experiments, but also make sure that the environment is captured. So that when you're trying to productionize these environments, you don't start from scratch figuring out what all did we do. You already have the blueprint on what should be taken and then deployed into production. Okay. So the key things we're going to be looking at, one component which we didn't look at in the last couple of days. You guys have access to the Research Hub, which you've been using primarily to access the slides, access the tutorials, the processes. You've been using the Q sandbox, which is primarily to run through these experiments and run through these labs. And I'm going to show you a little bit about the pipelining aspect of how do you actually put these things into production using what's called as a Model Analytics Studio today. Okay. So as I mentioned, there are a lot of interesting things which you'll have to figure out when you're kind of building out these applications in the enterprise. And as data scientists, you're kind of, in the past, quants and data scientists were typically involved only in the model creation, and someone else would kind of take the code and productionize it. But nowadays, you have to factor in, where does the code reside, whether it's on GitHub or whether it's on your Subversion or any other source control system internally. You'll have to figure out how to check in the code and check out the code. You have to be able to create environments so that other people can access. You may have to leverage hardware which may not be resident on your machine, so which means that you may have to be running stuff on the cloud. And then you may have to think about various interesting things like, well, if I am building these containers, how do I share it with people in my enterprise? How do I share it with people who are outside? So there are a lot of interesting things which you'll have to think about when you're deploying these models in an enterprise. Secondly, in the context of FinTech, there's a lot of interest in building out APIs or machine learning as a service. So what you could potentially be doing is you could have an interesting idea thinking about, well, if I can bring in these data sets, I can build out my own machine learning models, create a service, and make that service available, right? If you look at any data vendor who's out there, giving you newer data feeds, they're all charging you subscription fees for the amount of calls you're making for these APIs. So that's the new business model, right? So as a fintech, you could potentially be thinking, well, if I can bring in my ability or my scientist ability to process natural language processing data from Twitter or Facebook or whatever social media channels, augment it with some historical observations you've been doing in the markets, and then create a new data source and create a new alternative data source, which could be sold in the enterprise. And then the goal there would be to create an API or an endpoint so that any quant could connect to that particular API and download and use the outcomes of your machine learning as a service, right? Bloomberg made an announcement recently that they had a Twitter feed, and when the Tesla announcement, Elon Musk made an announcement about Tesla's potentially going private on Twitter, they were basically saying within less than a second, that particular Twitter feed hit their news feed within less than a second, right? So what that meant was you can now access APIs where you can get information much, much faster than what a human could process. So what that would mean is you will be able to build out your applications, connect it to various APIs, bring in those data sets, make those decisions, all those leveraging the hardware and the algorithms you can potentially be using. So you have to think about, well, what is the process by which my products, if you're building a fintech product, how is it going to be accessible to the enterprise, right? So are you going to be creating REST APIs? Are you going to be creating enterprise products and making it available? Are you selling the model? Or are you selling the outcomes of this model? Or are you creating a service or an application on behalf of somebody else? So all those are potential use cases you can think about in the context of fintech. And that all would require you to think about how do you deploy these machine learning models. And then if you're a student, obviously you've been learning a lot of interesting things. So you can think about sharing your knowledge. And a lot of companies are also doing this in the context of sharing how you can potentially use their APIs. So you can package everything and you can make it available to the enterprise. OK, so I'm just going to give you a quick perspective on what we are doing before we move to the case study. So most of the time in the last 3 days, you've been accessing the Research Hub primarily to gain knowledge on the various topics we've been discussing the last 3 days. We've been looking at various tutorials. And then we have kind of put together like step-by-step documentation to run the various experiments. That kind of goes to the process piece, right? And the 4 pieces we're talking about, that goes to the process piece on what those experiments are and how to leverage these experiments. The second component is the Sandbox, which is where you're creating these experiments, you're replicating these experiments, you're bringing in different Jupyter notebooks and trying out various experiments. That's kind of touching the 3 pieces in here, which is the code, which we were pushing it onto GitHub and making it available to you on a daily basis. The data was already there, and the environment, which we had packaged as Jupyter environments, right? And then the third piece is what I'm going to focus on today, which is to figure out how do we put all these things together and make it available for production, right? Now, in the context of what we are doing, we have created what's called as a let me just switch to. Okay, so this is basically the environment called as the model studio. What we did was yesterday when we completed all these three models, right? We basically took those three models and used Python to put those as pickle file. So those pickle files basically has all the model parameters. And then we have written an application which basically gives you this interface through which you can, in a live mode, kind of call the application which we've been building yesterday. Okay? So I'm going to walk you through the process of how did we get from yesterday's code to this particular application in the next couple of minutes. Okay? Okay, so it's basically taking a model which is in memory in Python, and you're packaging it and you're dumping it onto the hard disk, and you get a file which can potentially be reloaded into memory in Python. That's basically what a pickle file is. Okay. So let's kind of start out from where we left off yesterday. So yesterday we had our initial model. And when we had this model, we were basically experimenting using the Sandbox interface. We were saying, let's kind of get the model. Let's try out interesting things. Now, let me go in a second to here. So these are the various packages we have been using. One is pandas, numpy, matplotlib, cbon, scipy, sklearn, pickle. And then we added two more packages since yesterday. So in order to deploy these models into production, we are using a framework called Flask, which helps you build web-based applications. It's a Python-based framework to help you build web-based applications which you can share with the outer world. Okay? Then we're using another package called WT Forms. Okay, so now that we have the images which we created yesterday, so we were able to bring up the Jupyter notebooks and come up with these models. What we did was we basically took those models and we wrote another application. And what that application did for us is this Docker images which we are seeing. So you can potentially just prototype different applications and you can create new environments and say, well, this is whenever I run this application in production, it's going to be this particular Docker image which is going to be running in production. Okay? So this gives you a snapshot of the code. So in the future, if you wanted to go back and say, I want to try the code which I ran 6 months ago, you're just going to be running this particular Docker container, and that has all the code and the required environment. So you'll be able to replicate the code from where you left off in the past. Okay. Now, we didn't see a lot of features in here, but I'm just going to give you some screenshots. Basically, this tool, Sandbox, you're being using in a user mode. So in an enterprise, what happens is they're going to be the IT professionals or the DevOps professionals. So they can go in and they can say, well, for this particular package, we will need all these other Python packages. We need these other extra scripts we need to run. So they're going to be cobbling up all the resources which you would need to put together these containers so that you can run these models into production. Okay. So as you can see, it requires a lot more than just building out a model in Jupyter Notebook to get a model into production, right? So you will have to plan for it, especially if you're an organization wherein you are going to be using these models in production. You have to make sure that you have the right infrastructure so that you can bring those models into the respective environments. Okay, now the application which you have been currently building is primarily in Python, but Jupyter notebooks can also be used for Julia or for R, even for Go, and there are also some kernels for MATLAB too. So you can use the same environment for building out applications in different languages, and then you can package them and you can make it available for your end user. So it doesn't restrict you from just using Python. You can use any other programming language. We have a formal partnership with MathWorks. So if you guys are using MATLAB, so we have the ability to bring up MATLAB applications both in a live mode, so that you can prototype your applications in MATLAB on the web, and then you can productionize the whole thing by containerizing it and using any of their builder products to deploy them into production. Okay, And then this is just an example on R or RStudio. I know some folks were asking about potentially using R or RStudio. It's very simple. It's very similar to what we did in the last few days. Instead of using a Python kernel, just going to be firing up an R kernel or an RStudio environment, and you can build out applications. By the way, we have samples of R, Python, Julia, MATLAB. For the purpose of this crash course, we've just been focusing on Python. But if you guys are interested in any of the other packages, please do let us know. We'll be able to share some more applications. OK, the other thing you also need to think about is some of you reported back some errors. But as an enterprise, you need to make sure that you have to do error handling. And the code should be of the quality that you should basically be able to convey what the errors are if something went bad. Most of the times, error handling is an afterthought, and people don't typically focus enough time when you're building out applications, especially as quants and data scientists. We just want to get the work done. We don't put in all those try-catch blocks, and we don't put in all those error handling methodologies. But that's something you will have to factor in when you're building out a model for production. Because if something bad happens, it should not just crash, or should not just throw a random error message. It should give you something intelligent so that you can do. It should be an actionable error message. And as a platform, we have some tooling behind the scenes so that we can check the errors to figure out like what's happening, and we can debug, and we can make sure that those errors can be rectified. And that's something you need to factor in when you're building out models for production. And then you also have to think about all these security accesses. For example, you could potentially be having access to certain data sources. Others may have access to some production data sources. You could be prototyping applications, and it may not be ready for productions. How many of you have heard stories in the Wall Street Journal? It's like, oh, the test code got accidentally deployed, and something bad happened, and millions of dollars were lost. Right? So that's a major problem, which is even happening today. So you have to create those steps so that you can make sure that all the code you've been building is not just available to anyone for use. Right? And then you have to also think about, in the context of what we've been building, applications which could potentially be tested within your own enterprise, even without making it available in a production setting, which is basically why you need an environment like a sandbox. And the sandbox is basically an environment which is not giving you everything in terms of features, but it gives you a contained environment wherein you can try out certain use cases, and you can make sure that those use cases actually work before you can deploy these models into production. The reason why it's called as a Q sandbox is because in a contained mode, you're testing out certain things. It's not ready for production yet. But once you have all the code and all the testing and all the training and all the model selection you have done, now you have a model which is going to be ready for production. And that's what we're going to do now. Okay? So let's just kind of switch gears a little bit. So you don't have to use the Model Analytics Studio, but this is something we have created so that you can, in a logical way, create those workflows. For the purpose of this crash course, we have a very simple, interface through which you can run through it. We are not going to give you access to this because it's a little cumbersome, and you have to kind of understand some of the details. So we have already built a pipeline, and we are running it for you. So you're going to see the end result of this pipeline. But I'm just going to give you like a sample of how a pipeline would look in a production case, for example. So this particular pipeline, it has multiple stages. So you can orchestrate all the things you would want to potentially do. So in here, this particular stage is primarily just for scraping. So what it does is you have a container, you have an experiment on QSandbox, which basically takes the data and cleans it up, and then puts it on Amazon saying, OK, this is the clean data. We have done the scraping, and this is the clean data. And the pre-processing block takes the data from an S3 bucket on Amazon, does certain additional enhancements, does some pre-processing, and puts it back into Amazon. So the third step is a sentiment analysis block, which basically just trying to see how we can move from. The second stage. So here you're seeing the sentiment analysis block, and that basically is a Python package which does sentiment analysis in here. And the fourth stage is creation of various APIs. It's kind of going to Google, Amazon, and a bunch of other APIs to look for results and getting back results. And the third one, we are kind of using MATLAB to do additional analysis. So this is just an example of a production pipeline wherein you are potentially leveraging multiple packages, multiple environments to put together a workflow which needs to be replicated on an ongoing basis. Just an example of how you would potentially structure workflows in the enterprise. Now, the example we are looking at, let me kind of delve deep into it a little bit. So what we did was, when we go into this particular pipeline, so here what we have done is we have created, we want to be able to run this particular experiment. So what we did till yesterday, which was all the code we built and all the pickle code we built, we just built some additional code, and we are using Amazon. Amazon is one of the sponsors for this workshop, so all the things we are running is running on Amazon Web Services. So we built what is called as an AMI, or an Amazon Machine Instance, which is basically an image on the cloud on Amazon's infrastructure, which took all the pickled models which we built yesterday, and we built some additional glue code, which was able to put out this web interface. So that was basically this AMI. So that we created an AMI so that we can run this in terms of NAT. The second thing we did was we wrote some scripts to do post-execution. So because when we run this AMI, we want to be able to do a bunch of different things, right? So first we want to bring these models which we had written back into my Python code. And then we want to create API endpoints saying that if someone connects with us and passes these parameters, just run the predict function. And once you run the predict function, get me back the results, right? So that's kind of the deployment piece. Most of you won't understand what I'm talking about because you're not going to be writing the code in that level of detail, because this is where the production aspects come in, wherein you're actually deploying it and IT will be typically involved. But what happens is you will be giving them the models, the pickled models which we wrote yesterday. So those are the models you're going to be giving them. And then they are going to be taking that and productionizing it. This is one way of productionizing it. This is not the way of productionizing it. But this is one way of actually enabling it and making it available in production. And then when we run this pipeline, what's actually happening now is if you go into alpha.qsandbox.com, so this is where this particular app is running. And when you go into your environments, you're going to see another experiment in here. And if I click on this actions and say launch, so this is basically the application which is currently running on Amazon. So all the code we had been writing yesterday in Python, so all those are now available in a usable way. And this interface is your production application. Okay? So when end users are actually accessing your machine learning model, they don't go into Jupyter notebooks. They don't basically go and write code and see what Python syntax. They just see an interface which looks like this. And these are all the 16 variables which we have been talking about in the last 3 days, right? So we looked at it in a tabular format. We said, well, there are all these possibilities. So let's kind of look at it in a live setting just to get an idea. So we want to get a loan. And let's say I want to get a $5,000 loan. The repayment term, I'm asking for 60 months. So I want to be able to pay, I don't know, $300 as an installment. And there are all these grades of loan. So this one, let's just do the selection because this could be available in the databases in the future for when the model goes into production. So let me just choose a subgrade and a grade. So this is like the characteristics of the person. So here a person could say, well, I've been employed for 10 plus years. I'm renting a home. And let's say the annual income is $70,000. And then they had a field called verified, source verified, or not verified. So this is when you go into Lending Club and create an account, they will be able to verify whether you are genuine, right? Because they may ask you to provide some additional information to basically authenticate that you are the person who you are claiming to be. So that could be like a verified source. So it just adds to the risk. If someone is not verified and they're asking for a loan, potentially the interest rate is going to be higher, right? And the purpose, so yesterday we talked about like various reasons why people were asking for a loan. And again, the lender decides because it's a peer-to-peer lending place, right? a lender may decide, you know what, I'm not going to lend for people who are just taking a vacation or for some other purposes. If the person is, either doing debt consolidation or, investing in a small business, only those are the use cases for which I'm going to lend a loan. So the user may be selecting specific use cases. So let me kind of choose debt consolidation. So this is like the state. We talked about the different states from where people are coming from, right? So certain people, certain investors could potentially say, well, just because of business reasons, I'm only going to lend to people who are based out of Massachusetts, right? So that could be something you could potentially say in here. So debt to income ratio, we'll put in like, let's say 1.5 times that of my income as my debt. And then past due incidences. So this is something which you typically get a notification if you forget to pay your credit card bill, right? Well, so let's say for this particular example, it's 0. Inquiries in the past 6 months. If I've been attempting to get loans elsewhere, that all gets tracked in my credit history. So I'm going to, let's say, just say choose 0 in here. And then previous loan status. So let's say if I had applied for a loan in the recent past, and I was denied, and I tried to apply again. So that's going to be something which is tracked in this data set. Let's say approved. Now comes the algorithm choice. So yesterday we tried out a bunch of different algorithms. So we have made these 3 algorithms available online. One is a random forest algorithm, one is a neural network algorithm, and another one is a regression algorithm, right? So we have 3 algorithms. So let me start with random forest, and then we'll say submit. So this is the suggested interest rate. Okay, it basically passed these variables online to the running model, and it came back with a result 6.47% is the interest rate based on all the data sets it had seen, and this was the result. So let me go back and choose a different model. This is a neural network model now, and when I say submit, this one saying neural network is saying you should be charging 8.13%. Okay, and then I'll go back and I'll choose a linear regression model, and this was 7.4%. Okay, so based on the data we have kind of given to the model, so we had 10,000 records. So we let the model learn from those 10,000 records, and then created 3 models, and now we have a model deployed in production. Okay, so this could be a prototype app, or this could be the production app, right? The other thing you could potentially do is create a web app, and it could be a binary decision saying, we can't give you a loan, or we can give you a loan. That could be a classification application. Or it could be an application which we are using, in the context of, decision making, saying, well, there are 3 potential interest rates you could give. So I could potentially say, I'll give you an average interest rate of all these 3 models, right? But note that here there was no business rule decision making. Typically, if you go for a home loan, they have all these lookup tables, and your mortgage broker would basically look through okay, you have this particular interest rate, you have this FICO score, you own or you're renting right now. Putting all these aspects, they'll go through a decision tree and come up with a particular interest rate. This is a data-driven, machine learning-based model, which more or less kind of goes through the same decision-making process, but the parameters through which it has kind of learned to give weights to different attributes is based on what data it has seen in the past, right? So this is an example of kind of bringing out the technologies which are predominantly data-driven and making them kind of, it's abstracting out all the human involvement in the decision making, right? Because we are just leveraging historical data and all the decisions which has happened and using that to build out a model, right? And once you have a model, you can potentially just kind of productionize it either in the context of a service, or you have command line interfaces which we have also given, wherein you can potentially just kind of call it through through a command line interface and get back the results, or through a web app which looks something like this. Okay. Any questions till now? I know this was a little bit of hand waving because I can't ask you all to kind of appreciate what all it takes to write a web app and kind of call the the specifics in the context of what we've been doing. But what we did was we have been using just Python all along. The web app was also built in Python. It was built using Flask. Most likely, if you are a data scientist or a quant, you won't be writing these web apps. But the reason why we use Python is all the infrastructure we have been building is predominantly using Python. It just helps kind of extend the platform from where we left off in terms of building out a model to deploying it, productionizing the model. Yes, sir, you had a question.
Did you say as part of that deployment, putting the
Not the test data. We basically built out 3 models yesterday, right? So we are just deploying those 3 models, the pickle files of those 3 models. Yes, please. There are other frameworks you could potentially use. You could kind of have multiple, what do you call, applications. You could, you can like scale. You can use load balancers, and you can do interesting things. But there are also application frameworks you could build, Django and a bunch of others, where you could support multiple users. Yeah. Right. Absolutely. And here too, you can, all of you can potentially use it because each one of them would be a call, and it's fast enough that it's going to go and get back the results. Yeah. Any other questions? Okay. So we will kind of, basically, where we are now is kind of going through this whole 4-step process, right? So let's kind of do a quick recap of what we have done in the last 4 days. And then if you all go into your 4 labs, if you go into Sandbox, you should see a link. You can try this application in production in action. So you can actually put in your specific numbers and try it out. The 4 steps we have gone through, on day 1, we went through data pre-processing and EDA. Day 2, we went through building out a machine learning model. Day 3, we selected a machine learning model based on all the parameters we had. And day 4, we deployed this model into production, right? Now, as a part of your expectation for the certification, you should have received 2 assessments, okay? For people who have not filled out the assessments, we can track it because we are seeing how many people have filled it out. So you will all get a certificate if you complete both these assessments. It's going to be a digital certificate. The certificate will be mailed to you. If you go into the Research Hub in the 4th session, below that, there are going to be 2 assessments. There is 1 question for each day. So if you have done the lab 1, lab 2, lab 3, lab 4, you will be able to answer those questions. You could potentially also take a guess. It is as simple as that. But we want to make sure that you go through that effort of at least trying out the labs and convince us that you have gone through the process of attending all the 4 sessions. Day 1 and day 2 was in assessment 1. So you had 2 questions, primarily one from lab 1 and lab 2. Day 3 and day 4, after you complete today's lab, you will be able to answer the 2 questions. They are very simple questions. Most people have gotten it right. Okay. So that's the requirement for you to get the certification. So what we will do is once you complete all the 2 assessments, we will email you the digital certificate. We were planning to print out copies, but we have 60 people online, and we had to create a digital version of it. And we noticed that many of you still require a little more time to run through the labs. So what's going to happen is this production application, we're going to post another link. And that link will actually point you to the web app we just saw. And you can go to that web app, try out 3 different algorithms, try out different parameters, and get a feel for how would it be to run these models in production. Okay, and then you can complete the assessments, the last 2 assessments. Okay, yes, please. So the app is going to be the 4th lab. The production app is going to be running for the next 2 days. So you'll have time till the 15th to just complete the lab. For the assessment, you can have till, I don't know, maybe end of Sunday. It's just 4 questions. We could, if you really need time. Okay, we'll did you say Monday? So you wanted time till Monday? So okay, so we'll keep the labs running till Monday, and you will be able to like complete the assessments by Monday. Okay, that's fine. We'll extend the time till Monday. Note that each one of you have 50 credits, so you can start any of the 3 labs which you have created in the last 3 days, and you can rerun those labs and try out other things. And I'll go back to the slides. I know it was a very fast-paced course because it was just 4 hours. We had to cover a lot of material. So you can go and review some of these concepts and kind of try out these concepts in leisure. But the other thing is we are also doing a 2-day course, which is coming up next month. So if you liked what you saw the last 3 days and want to learn these concepts in leisure and want to try out a lot more applications, we are doing a 2-day course. And that's happening. This is the wrong link. Sorry about that. I think we had another link. So let me just, so I think this is the right link. The dates are October 18th and 19th. And you can kind of look at the content. We're going to be covering many more techniques and doing 3 more case studies. So you just had 1 case study. We're going to be working with 4 case studies, some in deep learning, some in traditional machine learning, and you can kind of work through all the 4 examples. Okay. And lastly, we would love feedback. I know you've been kind of working through these labs, and we are trying out the whole platform for the first time. So if you're interested in using it in your enterprise, or you would like to kind of know more about the Q Sandbox, please sign up. And you have 50 hours you can play with. And if you need any additional information about the potential use cases or want access to the ORStudio, you can potentially reach out to us. Okay, so any other questions? I'll be hanging around. I know we didn't spend a lot of time with Q&A. If there are any other questions with respect to the last 3 days or today's session, we'll spend the next 5 to 10 minutes or so. We plan to close at like 4:15, so we have another 10 minutes. So if there are any Q&A, we can answer them now. I'll open it up for questions. Yes, please. So let's kind of understand. So the question was about self-learning models. So could you give me an example? Like, what do you mean by? Right. Mm-hmm. Right. Absolutely. Right. Exactly. Right. Right. So what we are talking about is there are various ways in which you can do it. If you talk about like process-based approach to do something like that. So let's say you build this model and you deploy it, right? So you have made predictions for a particular interest rate, and people start defaulting for that particular interest rate. So first of all, you have to think about, well, should I directly deploy this application or have an additional criteria to first qualify people who can potentially repay or not, right? So you may have to think about building a classification model to first think about, well, whether this person is going to repay or not, and should I be able to give this person a loan or not, right? So let's say we build out this model, and we start at that model instead of the interest rate model. So let's say based on the criteria you have learned in the past, you are going to say, I'm going to give these people loans, right? And then you give them loans, and then you see defaults. But now which means that the model is now asking you to give loans but the people may not be repaying back, right? So at that point, you can adjust the threshold. What's the probability of default? So you can potentially, depending on the economy or whatever it is, you can say, well, I'm going to update the threshold so that when I'm making those decisions, I'm going to be stricter in terms of, making decisions for the loans, right? So that's one thing you could potentially do. The other thing you could potentially do is there are going to be regime changes. As the economy changes, you're getting new data points. So you can augment your model. So the retraining of your model could happen at a higher frequency. Instead of you training a model once and deploying it and retraining it every 3 months, you could potentially say, I'm going to train my model on an ongoing basis. And if I have a temporal set of data, if you're, let's say, giving 1,000 loans per day, you could potentially have a window saying that I'm only going to train based on the last 3 months of data. And then keep my model refreshed so that I'm always using this sliding window to keep my model as fresh as possible, right? Then you can also think about augmenting your data and weighing your data points, the most recent data points, much higher than other ones. So you can replicate your most recent data points or the ones which you think are very influential so that the model kind of puts more weight on the most recent data points. So there's a lot of procedural and process-based things you could potentially do to make sure that your model is fresh. Now, a self-learning model is, it's kind of probably still out there. We don't have very many techniques wherein it can learn on an ongoing basis, especially for these kinds of problems. But there are some online learning algorithms, especially in a trading context, or if you're trying to do interesting things at a very high frequency, you can potentially think about. But for these kinds of models, you have to set up the process so that you can accommodate. Any other questions? Yes, sir.
More, sort of a top-down question. If I took that same data and randomly chose to build my model based on 20%.
Sure.
If I ran that exercise with different 20%, right?
Well, right. So yeah, so the way you are trying to do this 80-20 rule, right? So you're basically saying, if 100% of the data, I'm taking 80% to train, testing it out into 20%. And then now you have a model, right? Now you can switch the data around, you can mix the data, and then use a different 80%, then come up with another 20%, and then you can, it's going to be a different model, for sure. So you're now kind of thinking about which model among all these combinations you can potentially use. So that's where you're potentially using cross-validation, right? But once you gravitate towards a model based on the error metrics, which you find is the best model for your deployment, right? Now you're keeping your training and testing data away. And this model is going to be presented in the live setting. And in the live setting, you don't know what the labels are going to be, right? Because that's where you're predicting a number or predicting a particular class. As Raj was mentioning, if it's a class-based decision where you're saying, should I give a loan, yes or a no? Let's say you say yes, and then in the future, you determine this person defaulted, which means that I should have given this person a no, right? And at that point, you have new data, which the parameters, and now you know that it should have been a no. You can use that to retrain your models. Okay. So in the context of replicability, you can choose the seeds in the random seeds so that you can replicate the experiments. But you need to figure out which is the most generic model you can potentially do in order to deploy it. You had to choose one model to deploy into production for sure. Yeah. Yes, please. Any other questions? Any questions online? Okay, so I don't think we have any questions online. So I want to end the session. Thanks so much for coming all the 4 days. I saw most of you, made it a priority to come on a business day to attend this class. Hopefully the sessions were helpful. It gave you a clearer perspective of what it means to build out data science applications. I need to acknowledge the support of Babson College and the Cutler Center. Thanks so much for hosting us. And also Amazon Web Services and Google for providing credits so that we could run these labs. And last but not the least, the FinTech Sandbox. We've been doing amazing things and making sure that the community is engaged and also bringing us all together so that we could have this learning session. And we are based out of Boston, and I've lived in the Boston area for the past 19 years. QuantUniversity is a local company. So if there's anything we can help you guys with, either in terms of training or consulting, please do feel free to reach out to us. We are in the business of solving business problems. So let us know what we can help you with. And if there are other programs we can bring to the area, please do let us know. And hopefully, we'll see you guys in the near future. One thing I want to mention, which I didn't get a chance to mention, the machine learning workshop. What we're going to do is we're going to send out a note with information to register, kind of a thing, to incentivize you to complete the certification process. So if you complete the certification process by Monday, we will send you a code which will take off 50% of the workshop. Okay. So if you're planning to attend the workshop, you have one more incentive to make sure that you complete the certification so that you're prepared to come to the workshop, which is going to happen next month. Okay. So at that, Patrick, do you have a few words to say as we end the session?
I just wanted to thank everyone for coming. As Sri mentioned, it takes a lot of time. Session. Hopefully we'll be able to communicate.
Oh, thanks all for coming. Thank you.